Hello everyone, welcome to Vision Tech Solutions channel. In this lab, I'm gonna show you how STP root bridge election is working, and then we will verify once the root bridge is elected in our network. As you are aware, in the previous video, I talked about the spanning tree mechanism and the rapid spanning tree, how it works, and also I talked about the STP root bridge election. And so the root bridge or STP spanning tree root bridge election is based on the priority and the MAC address fields of the bridge ID. As you know, the bridge ID is the bridge or the switch MAC address plus the priority. So the device with the lowest priority value is elected as the root, and if there is a tie in priority, the device with the lowest MAC address will be elected as the root. So let's go to the topology that we are going to work on. So we have 4 2960 switches that are interconnected with each other with redundant links. As you can see, between each switch we have 2 links going to the other one. So and then you have redundancy in the network. You know that the spanning tree blocks some ports in order to prevent loop from happening in the network. So for this lab, in order to verify and to see the STP root bridge election, I have prepared some tasks that we will do in this lab, and then we will do the verification. So the first thing, I will configure the inter-switch links between switch 1 and all the other switches as a static 802.1q trunk links. And of course, by default in the packet tracer, the iOS version that we have for these switches, it is by default 802. So we just change the mode to trunk and then disable all the other inter switch links. It means we will disable all the other ports that from, for example, switch 2 goes to switch 3 and switch 4. So only from switch 1 to all the other switches, the links are up, and I will put them in trunk. So let's do the first task. So I go to the console switch 1. Of course, I have changed the host name to switch 1. So I go to the conf mode, and I have to put all these ports from fast Ethernet 01, 02, 3, 4, 5, 6 into the trunk. So I go int range fast Ethernet 01 to 6. If I want to select the encapsulation, I have to put switch port trunk. Of course, in this iOS version of this switch and in the packet tracer, I cannot choose the encapsulation. As you can see, I don't have the command for encapsulation, but on some other switches, like the physical switches with a different iOS or newer iOS versions, or even EVNG, you can choose the encapsulation. But since I don't have this command, I just change the mode to trunk. I don't need to put 802.1q encapsulation. It is by default using 802.1q. So I put them all in the trunk mode. So that is the first task. Disable all other inter-switch links. It means I have to go to switch 2. So only these two, 5 and 6, should be up. So conf t int range. So 3, 4, 1, 2, and 3 and 4, I should shut down those ports. So range fast Ethernet 01 to 4, I shut them down. And if I show IP interface brief, as you can see, 1, 2, 3, 4 are shut down. Only 5 and 6, which are going to switch 1, are up. That was switch 2. I will do the same for switch 3. So for switch 3, only 1 and 2 should be up. So conf t int range fast Ethernet 0, 3 to 6. I shut them down. If I show IP int brief, so only 1 and 2 are up, which is going to switch 1, and the other ones 3, 4, 5, and 6 are down. The same for switch 4, as you can see. So switch 4, only 3 and 4 should be up. So 1 and 2 and 5 and 6. 1 and 2 and 5 and 6 should be down. So int range fast Ethernet 0, 1 to 2, shut them down, and 5 and 6, shut them down. Show IP interface brief, as you can see, only one and 2 and 5 and 6 are down. Only 3 and 4, which are going to switch 1, are up. Okay, so that was the first task. Let's go to the other task. It says configure VLAN 2 on all switches, and so if we want to configure VLAN 2, we have to go to switch 1 and just issue the command VLAN 2. I will do the same on switch 2. Conf t VLAN 2. I will go to switch 3. VLAN 2. VLAN 2. Okay, so I configured VLAN on all VLAN 2 on all switches. Now it says configure switch 2 as the STP root bridge for VLAN 2 using the lowest priority possible. So as I said, bridge ID is a combination of bridge priority and the MAC address. So if we suppose that all these bridges have different so a default priority. So if I put one bridge with the configure one switch with the lowest priority, I can put that switch as the root bridge, or I can choose that manually as the root bridge. So to do this, I will go to switch 4 and I issue the command spanning tree VLAN 2 priority 0. So if switch 4 goes down, switch 1 should take over the STP root bridge for the role of VLAN 2 using the second lowest possible priority. So in order to do this, if I want to configure another switch as the second lowest priority, so as you know, the priority of these switches are not random numbers. So if I go here and issue the command priority, and so it is from 0 to 61 44 440, and of course with the increments of 4096. So the first one is 0, the second one is 4096. So what I will do, I will put the second number, which is 4096, for switch 1. So if I go to switch 1 and I put the spanning tree VLAN 2 priority. So as you can see, I can choose between 0, which is the lowest, to 6144, 61,440. So and with the increments of 4096. So I'll put 4096, which is the second priority. So that is all we wanted to do for this, but also we have to put the so we shut down the ports, we put the and the ports into trunking in switch 1. Also in switch 2, 3 and 4 I put the ports going to switch 1 as the trunk port. So I'll go to switch 2 and the ports that are going to switch 1 are 5 and 6. Int range fast Ethernet 0, 5 and 6 switch port mode trunk. I will do the same for switch 3. Range fast Ethernet 0, 1, 2 switch port mode trunk, and switch 4. Int range, so switch 4 are ports 3 and 4. Fast Ethernet 0, 3 and 4 switch port mode trunk. Okay, now our configuration and all the tasks are done. Now we have to do the verification. So if I go to switch 4 and issue the command show spanning tree for VLAN 2, so as you can see, this switch is elected as the root, and it says the bridge is the root. As you can see, all the ports going to switch 1 are in forwarding state with the cost of 19. So actually this is like the root bridge, and it's all its ports are in the forwarding state. But from the other switches, they will elect one port which has the lowest cost as the root port. Now we will verify that in other switches. Let's go to switch 1. So this switch is we have show spanning tree for VLAN 2. So as you can see, this is not the root bridge, and as you can see, we have two ports going to switch 4, which is 3 and 4. Now which one is put into the forwarding state? It is fast Ethernet 0, 3. They have the same cost, so the cost is the same. When we have the same cost, so the port with the lowest port ID number will be elected as the root port. So that is the root port actually. Fast Ethernet 0, 3, the port which is going to the root bridge. And of course the other ones, we have alternate port, and some of them are put into the designated forwarding, but this port, one of the ports will be blocked into blocking state. It is put into blocking state. Now let's check this on switch 2. And also I wanted to show you something in switch 1. it says that the root ID, and this is the MAC address of the root bridge. So if I want to show you here, so this is 27C5, 27C5. If I go to switch 1, 27C5, it shows the switch 4 as the root bridge. It is showing the root bridge ID, and this is the bridge ID of this switch, which is the priority 4098, and this is the MAC address. And as you can see, the priority is 4096 and system ID extension is 2 will be added to the bridge ID priority. If I put the bridge ID priority to 0, system extension ID will be added and it will be 2. So if I go to switch 2, show spanning tree VLAN 2, so as you can see, it is showing the, again, root ID 27C5, which is the MAC address of the root bridge, and of course this one has this priority, and this is the bridge ID of switch 2. And as you can see here, we have 2 ports going to the root bridge, 5 and because 1, 2, 3 and 4 are actually shut down, and we have only ports going to switch 1. So 1, 6 is put into the forwarding blocking state, and 5, which has probably the lower cost, will be elected as the forwarding, as the root bridge. So the cost is 19 both, but this one has a lower port ID, that's why it is elected as the root port. Let's go to switch 3, show spanning tree VLAN 2. Again, the same thing here. We can see that fast Ethernet 101 lower port ID is elected as the root port. So the port going to switch 1 and then switch 4. And it shows the, again, the root ID and 27C5 is the MAC address of the root bridge. Now, one of the requirements was if switch 4 goes down, switch 1 should be take over the STP route. So in order to do that, as you know, these 2 links are shut down. These 2 links shut down. So we just shut down these 2 links. It means that this switch, it will go down. So there is no other links to go to the other switches. So on switch 1, if I go to T and int range fast Ethernet 0, 3 to 4, and I shut them down. So it means show spanning tree VLAN 2, and now look at this. This bridge is the root now, and with this priority. We put the priority 4096 plus 2, which is the VLAN number, and that is now the root bridge. Now, if I go to switch 2 and show spanning tree VLAN 2, now AAD3 is the MAC address of the root bridge. Let's look at this switch and AAD3, which is switch 1. So from switch 2 perspective, now switch 1 is the root bridge, and look at this, fast Ethernet 01 is the root port. So it has the same cost These two ports have the same cos going to the root bridge, but the one with the lower port ID has been elected as the root port. Let's go to switch 3. Now show spanning tree VLAN 2, and as you can see, switch 1 is the root and fast Ethernet 01 is elected as the root port. So this lab we learn how root bridge is elected in the network. It is based on the bridge ID, and the bridge ID is the combination of the MAC address and priority. So the switch with the lowest bridge ID will be elected as the root. So we put the priority of the root bridge as 0. We put the priority as 0, and it was elected as the root bridge. And the second lowest priority was 4096, because we can choose from 0 to 61,440, and with the increments of 4096. So this concludes our lab for the STP root bridge election. I hope this lab has been useful. If you found this video useful, please don't forget to like and subscribe, and we will have another lab for the spanning tree in the next video. Thank you for watching.